Hello, everyone. This talk is about linear regression, and it's basically if we find a correlation, can we use that straight line that we did in the previous section to use it as a predictor, we're going to call it. So we're going to start here. Given a collection of paired sample data, the regression line is a straight line that the scatter plot of the data. The regression equation looks like this. Y hat equals A plus B x. Now, I want to make it clear. In algebra classes, you write this y equals mx plus b. M is b in this case. A is the other b, if that's a little confusing. So it's like mx plus b. In stats, we write it like this for linear regression. X is called the predictor. And it's the independent variable versus the response, which is the dependent variable. Picture like you're going out to get some gas for your car, and the predictor is going to be you choosing the number of gallons of gas that you want to buy, and the response is how much it's going to cost. So notice that the response completely depends on how many gallons of gas you get, or the predictor. So let's start with an example. And here are IQ scores between couples. N is 20 in this case. And the linear correlation coefficient is here. So they already got us R. Let's use a different color. Here's R. In a minute, we'll have to do that ourselves. And here's the linear regression line, where X is the IQ score of the husband and Y is the IQ score of the wife. Now, I want to point out that there's going to be one of two ways that we're going to use a predictor. One of them is the linear regression line. That's only if there's a correlation between X and Y. These are IQ scores between husbands and wives. If there is no correlation, then we use the means. So this is Y bar. So that'll be our best predictor if there is no correlation. So let's see if there is a correlation. So let's start with our null hypothesis. And here we're going to have, once again, here's our -1, and our 1, our 0. This is R. And N is 20 in this case. And we're given an alpha of 0.05, so I go to my table. Here's my alpha, 0.05. N is 20, so here it's 0.444, negative and positive. Now, to be clear, once again, this is the no correlation versus from 0.444 to 1 or -1 to -0.444. These are the correlation. And if we find that there's a correlation, then we will use the linear regression line. Otherwise, we will use the mean if there's no correlation. Now, you'll notice that we have an R already set up for us right here. 0.916, that's way over here. So there's definitely a correlation. So we are going to use this as our predictor. And here we go. Now you'll notice, what is the best predicted IQ of the wife given that the husband has an IQ of 102? So this is going to be 1 times 102, which is going to give us 102. 2.3. So this is the predicted IQ of the wife, of a husband who has an IQ of 102. And everybody, you should notice that this particular equation, the woman would always have the higher IQ, which I'm not debating, but just pointing that out. Let's take a look at another one. So we have a sample of 100 women, so there's our N. And their heights and pulse rates are measured. Linear correlation coefficient is 0.207, so that's our R. Pardon me again, I have a cough. And we have the mean heights, and the pulse rates. And what is the best predicted pulse rate? So our two options are going to be, if there's a correlation, then we'll use 0.9 plus 0.92x. No correlation, then we will use y bar, which is 72.4 beats per minute. So let's see if there's a correlation or not. Once again. So once again, n is 100, and we have a significance level of 0.01, so we're going to have to go to our table here. And here's our alpha 0.01 way up here. And 100, we're maxed out here, so that's 0.256. So here, 0.256, negative 0.256, and here is, straight line there. This is our no correlation zone, and this is our correlation zone. Zones, I guess I should say. And they give us an R, 0.207, and you can see that is just inside. The no correlation zone. So, no correlation. No linear correlation, I should say. So use the mean, 72.4 beats per minute, as the best predictor. So this one up here, we found a correlation, so we used the linear regression line as our predictor. This one, there was no correlation, so we didn't. We used the mean. Example 3. So now we have, excuse me, we have a bear chest size compared to the bear's weight to see if there's a linear correlation or not. And we are going to, now you notice we have data here, so we're going to actually do the full-blown everything in this case. So we're here. It looks like n in this case is 1, 2, 3, 4, 5, 6. And we have our significance level of 0.05. So let's draw this out. Again, 0.05 and 6. So here's my threshold, my 0.811, positive and negative. So 0.811. And once again, this is the no correlation zone. versus the correlation zones. You can see they're quite small. So we need to get R. I have already put the data into here. So list 1 and list 2. You can see the 40 and the 227 and so on. So I'm going to once again run stat tests linear regression t-test. And this is list 1 and list 2. And you can see I have my R, which is 0.979 actually. Ooh, that's 979. So we are definitely in the correlation zone. So now we need our linear regression equation. Now remember it's y equals a plus bx. Well, very nicely you can see we have a and b. In fact, this fills in very nicely right here. Yeah, 0.0. And then b in this case is the 12.5. So this y hat equals negative 308 plus 12.5x is the best predictor. And we're going to actually use that, and they want to know when the actual weight is 273. So oh, I'm sorry. I had that wrong. So we're here, and we're going to compare it to here. So y hat is negative 308 plus 12.5 times 41. And that comes to about 203.3. And so using our predictor, our linear regression line, we get this here. Now, it asks a further question, is this close to the 273? And I'm going to say, no, it's not. So this appeared to be a correlation, and the prediction was not all that great. Last part. Darn cough. All right. So here we have, I think these are ages of actors and actresses that won Best Actor. Yeah, we're here. And once again, we're here, and we'll see what our threshold is. See if there's a correlation or not. And it appears that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n is 12 in this case. And our alpha is not here. What did I use for alpha? Let me look at my notes. Alpha we use 0.05. So we use what we did with the previous one. So alpha is 0.05. And actually, I think in this case it won't matter. N equals 12, 0.05. 0.05 is here. N equals 12 is here. So 0.576. Here in the middle is the no correlation, and out here is the correlation. And once again, I've already preloaded my data into list 3 and 4. I can show you. So list 3 and 4, you can see 3 is the 28 and so on. So I'm going to go stat tests, linear regression t-test, and list 3 and 4, and calculate, getting us our R, 0.36. So we can see there is no linear correlation. So we're going to use y bar as our predictor. And we can get y bar because y in this case is best actor. And so if I go into my stat, I can calculate one variable stats on list. So that'll be list 4. And even though it says x bar, that's actually y bar. And you can see it's going to be 44.83. This is about equal to 44.83. And that's years old. Is the best predictor in this case. So once again, if there is a correlation like the one above it, up here, then we use the linear regression line. If there is no correlation, then we use y bar as the predictor.